Hello, welcome everybody on DevOps Pro Europe conference on architecture and DevOps teams track. My name is Piotr Wachulec, and I have a big pleasure to track that to host that track for you, because personally it's also my passion, the architecture and DevOps culture. So I'm working on that also in my professional career. So today we will start with the session which prepared for us Ari Palo. So Ari will tell us something about diagramming, about documentation. So hello Ari, nice to meet you.
Hello, nice to meet you too.
Okay, when I prepared, when I was preparing for that opening stuff, I thought about that agile manifesto and agile concepts, yeah, that software over the documentation, and you are trying to say us that, hey, you have to prepare kind of documentation, kind of diagram, so
Yeah,
and everybody is, let's say, is not like that doesn't like to prepare the documentation, and everybody is shouting that, hey, where is the documentation for the project?
yeah.
So how about this?
Yeah, well, I actually don't advocate anything like a waterfall or anything like that, that you need to spend too much time on the documentation and architecture diagrams. Instead, what I try to say is that you can actually move faster by doing these architecture diagrams, doing a bit of planning beforehand, because you can actually find many problems out beforehand when you just, putting some things on down on the paper. It's kind of the same thing as for, user interface developers. They are doing mock-ups and prototypes to sort of quickly find issues. This is kind of the same concept, that you're trying to identify issues. They can be cost or performance issues or anything, but you quickly find them out. So that's kind of the idea here, and not do like a detailed overview of everything beforehand. And that's something that you can also do all the time. It doesn't have to be just at the start. You can do it continuously and so on.
Okay. So now it sounds quite interesting. So the floor is yours. Keeping fingers crossed for you and for your speech, and I hope
Yeah,
that
thanks.
everybody will have fun. So
Yeah, and I'm going to just share my screen, and let's see. You should be seeing the screen now.
yes, we are.
And yeah, and welcome to this Communicating Cloud Architectures talk. First things first, my name was Ari Palo, and I work at Alma Media. I've been there 11 years now and currently working as a lead technologist there. I had a background of being a freelancer doing PHP, WordPress, front-end design before that. But nowadays, I'm mostly working with cloud architectures, and my favorite programming languages at the moment are TypeScript and Go, although I constantly find myself making up excuses to learn Rust someday, but we'll see how that one goes. I've been using AWS since around 2014, and last few years I've been heavily focusing on serverless. And also I'm an AWS community builder focusing on developer tooling. And there's also some links and social media handles, so feel free to connect with me after this talk. Briefly, some context about Alma Media, which is a digital services and media company operating in 10 European countries. We have over 50 brands, 1,500 employees, about 300 developers. And we started our cloud journey around 2012, and AWS is our primary web application development platform, so to say. We do have also GCP and Azure as well, but they are a bit more for a bit more specific purposes. So AWS is our kind of a primary cloud platform. And we've been doing a lot of stuff in AWS these last years. At the moment, I actually checked this yesterday, we have exactly 170 AWS accounts. So there are a lot of accounts and a lot of people developing stuff on top of AWS. And again, we are really, as the whole company, we're really like doing things in a serverless first manner. Not everything is serverless. Of course, we do have quite a lot of EC2 instances, virtual machines running there, a lot of containers, all that stuff. But we still kind of prefer, when we can, to use serverless patterns in AWS. Other thing that we really like is using infrastructure as code. We've been pretty much from the get-go using some kind of a infrastructure as code or configuration model. At first, we had like configuration management tools such as, Puppet and Chef and Ansible and things like that. But going forwards, more and more these kind of cloud native technologies or like more cloud specific tooling came around. For example, we started using more and more CloudFormation, which is, I still think that's probably the main configuration or the main infrastructure as code tool that we use in Alma. But we have some Terraform as well. But these last few years, we've been also using CDK, the AWS Cloud Development Kit, pretty heavily, and we're doing quite a lot of stuff with that. But just to sort of summarize that, we're pretty heavily in AWS, a lot of developers and sort of cloud native developers that are developing directly and building things directly into the cloud with the cloud mindset. And we're using infrastructure as code and preferring serverless. So that's kind of at the context for this talk and the sort of the point of view that from where I come from. So there are a lot of these. This is just some imaginary system, some kind of and this actually has a lot of stuff that you wouldn't probably necessarily have in a single system. But this is kind of an overview of options that you often see in our implementations, that you might have some event-driven setups provided by EventBridge event buses or AWS SNS notifications or SQS queues. Often there's like API gateways for RESTful APIs, AWS AppSync for GraphQL APIs, and even my favorite product in AWS is the Amazon S3 bucket. So you can do actually quite a lot of things with S3 and various integrations with it. And then we use quite a lot of AWS Lambda compute. But as I said, we do have a lot of containers, but we also have those EC2 instances as well. Then we, like maybe last year, we started using AWS step function workflows quite a lot, where you can sort of create these well-defined tasks that either perform in SQL or in sequence or in parallel, and they have different conditions. And it's a really nice way to, again, describe workflows. We have different databases that we use. We use both traditional relational databases, but we also use NoSQL databases such as DynamoDB. We have all sorts of data collection tools in use and data analysis tools and different kind of warehousing tools in use. So there's a lot of stuff you can build and that we are also building with AWS. But this is just to set sort of the context for this topic. Always when I talk about making architecture diagrams in AWS, or in any cloud solution, there's usually quite many people that are then either pointing out or asking that why you should draw them yourself. Shouldn't you just generate them somehow, because you're already doing some kind of a infrastructure as code? So you could possibly utilize your tool, may be CDK, Terraform, CloudFormation. There are tools out there that can generate architecture diagrams out of it. Then there's other tools. Here's just some screenshots of various products that support this architecture diagramming and generating those. There are other tools that can actually inspect your current setup or for example, the resources you have in an AWS account, and then they can generate these nice looking diagrams out of them that sort of describe what is your current status or current situation there. And it's quite handy actually. But where I see the biggest benefit for these tools is that you're jumping, let's say you need to jump into a new AWS account, or not new, but existing AWS account that you don't really know anything about it. And maybe the developers didn't have a good documentation in place, and you need to start understanding what's happening there. So in these cases, these tools, I'm not sure why I have the notifications on. Sorry, I'm going to just quickly disable that, like so. So yeah, let's continue. So these tools are great for inspecting your existing situation and sort of generating a report what's happening there. Then there are those tools, for example, CDK Dia, which can generate this diagram out of CDK AWS Cloud Development Kit code. And there was something, I can't remember the name, but there was also a tool for Terraform that basically analyzes your Terraform plan and creates a diagram out of it. I don't see a huge value in those kind of tools that generate diagrams from your, let's say, deployments that generate those diagrams during deployments, because you kind of, when you're working with your infrastructure code, you kind of should be knowing already what you're doing. So it doesn't necessarily provide that much value. Sometimes it can, but sometimes it don't. But so to sort of summarize my opinion about these tools is that they're useful when you need to jump into an existing setup and start analyzing from that which kind of a resources it has, which kind of a dependencies there are between resources, etc. Then these are really useful. So definitely take a look into those. But one thing is that some of these tools can become quite expensive. For example, AWS Perspective can become quite expensive, especially in larger enterprise setup. So there's also for these third-party tools, there's the pricing that you need to sort of evaluate that is it worth for the end result what the tool is providing. But it depends, as usual. But the way I see the most or the biggest benefit from these cloud architecture diagrams is that they are best suited for communication, not inspection. And they are best suited for design, not debugging. So what I mean with that is mainly that when a team is starting, well, it can be just a single person. It benefits them as well. But usually in this team development scope, this make the most sense. When you're starting a new project, as I kind of said already in the introduction, that I'm not advocating a waterfall approach where you specify everything beforehand before you implement anything. But I still see a value in some form of planning and design before you actually start implementing things. Because if you're just starting immediately writing some infrastructure code, let it be with CloudFormation or CDK or Terraform or whatnot, you can actually accidentally end up spending quite a lot of time in unnecessary work that you make some silly mistake already at the get-go. And as also in the introduction, I kind of made this comparison that it is for example, user interface developers, front-end developers, user experience designers, etc., and product people. They often don't start by developing and programming the user interface immediately. Often they start, especially in larger companies, they start with a mock-up or a prototype or something that they can actually try out and figure out the problems like in early phase. And even that they do, when they do this, nobody says that they're doing waterfall process. Instead, they're being agile and fast, because they are prototyping fast and finding the problems fast. And once they've sort of figured those initial problems out of the way, then they can start the development of that user interface. So kind of the same idea for cloud architectures, that you try to identify potential problems as fast as you can by doing a bit of planning, a bit of architecture diagramming and things like that. And once you have something in place and some initial plan, then you can, of course, open up your editor and start building things in CDK or Terraform or CloudFormation or whatever the tool is that you're using. And that is super useful. So let's see how you can start building these or drawing these diagrams, and how you can start designing what you're trying to build. But before we go into that, I still want to say something about the communication and not inspection. Those tools that I mentioned a couple of slides ago that can generate this diagram out of your existing resources. As I said, they are useful for some scenarios, super useful in some scenarios. But when you're starting a new project and you're doing some kind of a architecture diagramming, it's mainly focused on communication. So you have a team of developers, and usually there's one or two that are kind of leading the sort of architectural work there. So it's good that they can provide this architecture diagram and communicate to other developers that what is the intended idea here, what we're trying to build. And let's say time moves forward, few weeks, few months, maybe year something, and people keep developing and hopefully also somewhat updating the architecture diagram. If there's like new people coming to the team, it's a lot easier to get them started when you can just show the diagram and sort of explain the overview, why the things are like this. Also, often in my position, and why this topic is really important for me, is that we do have a lot of developers in-house, but we also work with subcontractors quite a lot. So often I get to this sort of situation that I need to evaluate some kind of architecture that some third party has made. So it's kind of annoying when they just send you a GitHub link and say that, okay, read the code. And so, okay, of course I can do that, but it's kind of a waste of time if it's not necessarily a waste of time if it's just one people, but if everyone that has to understand what's happening there needs to always at first read the code, it takes quite a lot of time. If you have some overview, at least, that helps quite a lot. But let's go actually to sort of tips that how you can start building these diagrams. First, of course, you should choose some kind of a tooling to do this. There are a few things that it should do always. This, again, depends on your context and where and in what kind of a situations you're working. But most often, it should work for your whole team and organization. So it probably shouldn't be, for example, operating system specific. If you have, let's say, developers with Linux machines, Mac OS machines, Windows machines, then it's really annoying if it's limited to one operating system. For example, when I started really doing these different kinds of diagrams several years ago, I used this tool called OmniGraffle. But then we started having a lot more Linux developers and Windows-based developers. So OmniGraffle is only macOS application. So they couldn't really, contribute to those diagrams. So that was super annoying. So I recommend choosing something that works for example, if you're 100% macOS shop, so everyone has a Mac in your organization, then it might be okay to use Mac specific application like OmniGraffle. But again, think of this that you're not limiting the access based on, for example, operating system. So choose a tool that supports many things. It probably should have a reasonable licensing or pricing. Again, depends on your context. If you have a lot of money to pour into diagramming tools with high-priced licenses, then it might be okay for you. But again, what I want to point out that it's not the price itself or the licensing itself. What I mean here is that you don't want to limit access. Let's say you don't want to just have one architecture god that is responsible for architecture. You want everyone in your development teams to participate somehow in it, at least to be able to view the architecture diagrams. That's important, but they should be able to contribute. So there shouldn't be a blocker for the contribution just because the license, you don't have enough licenses or you don't want to spend money to give a license for someone who just contributes sometimes. So that is one thing you should think. Then it really should be able to export to SVG graphics because that's the de facto vector graphics format. So you can export to various documentation or, for example, GitHub READMEs or whatever. So that's a definite thing to have. Then there are some optional things like maybe it could have these official cloud platform icon assets available as built-in, so you don't need to fetch them from some website and then drop from your file system into the application instead. Maybe it could have these built-in that you can just somehow search some kind of library within the application. That's good to have, but that's again optional. Another optional thing, it might be useful to have it to be version control friendly, so that you don't need to, that you can actually version control the source files for it with the actual code that you're developing. Might be useful. Another useful thing, if it's a version control friendly format, so it might be useful if you can actually export that source file to SVG using in your CI system, for example, in GitHub Actions. We have these setups that we store the source diagram into the repository that contains the code for that specific service, and then the GitHub Actions can actually export always the diagram to SVG, and then always the README will contain the latest version of the SVG, because nothing is more annoying than an incorrect version of the exported SVG that doesn't actually match the source source file that from where it was exported. And it might be useful if it's embeddable. So you could embed those. Well, if it can export to SVG, you can of course embed that. But some tools allow you to integrate those diagrams somehow directly to, for example, ticketing systems like Jira, and even some tools support that you can actually edit them in your editor, such as VS Code. There are setups like this. And one tool that I really like is the Draw.io, or Diagrams.net. I think it's the official name, but everybody knows it as Draw.io. It supports all of these. But I'm not saying you should use Draw.io. Use any tool that fits your purpose. But these are just some points that you should be probably thinking about. And again, you probably don't require all of them, but just be mindful when choosing the tool. Then always use the official assets and icons that are provided by the cloud platforms. Each major cloud platform provides these. GCP has their own that you can go and download. They have examples there. Same goes for Azure. They have examples and asset icons that you can download from there. And also same goes for AWS. I see too many times people when they're making up these or drawing these architecture diagrams, they are going to Google image search and searching, let's say AWS Lambda icon or something. That's like, don't do that. Use these official assets. They contain the latest versions, and they have all quality icons in various formats, SVG and PNG and EPS and so forth. So use these. And an example from AWS is that they actually have, for many tools, there are already built in their icons. So you can actually use the tool directly, and there's some kind of a library from which you can export the various assets. There's also, you can download the zip package containing the icons, etc. And you can also download PowerPoint. So if you're showcasing a lot of architecture diagrams in PowerPoints, like I'm doing today, it's useful to download that PowerPoint file, because you can then copy paste those icons and arrows and all kinds of graphics from PowerPoint to PowerPoint, and they work really great. But other reason to check out that PowerPoint is that it has quite good examples and explanations on how to group different kind of assets and how to really draw these. And why I'm saying this is important is that you really should use the way the cloud platform has defined to draw these diagrams. That's really beneficial, because once you sort of understand how these diagrams work from the cloud vendor, like let's say these AWS diagrams, it's really easy. You can jump from project to project and understand how these work. Or, for example, if you need to talk with AWS, let's say you have an AWS technical account manager for your company, then if you need to talk with them or some AWS specialist, you just show the diagram and it's immediately familiar to them, and it's easy to get going from there. One thing especially applies to AWS: don't use these legacy icons. Always use the latest versions. Especially AWS, these old icons were really bad. It was super hard to understand what these mean. I'm pretty sure if there's some people in audience that have even used AWS for some time, they probably won't guess which these are. Some might if you've seen this a lot, but they are still pretty obscure. But the newer ones are much more clear. For example, the Lambda service, it has the Lambda symbol. S3 has a bucket symbol, because in S3 you use buckets, etc., etc. So definitely use the newer. And it's annoying that you often see like people mixing these old ones and new ones, and you don't really know what is what. Always use the newer ones. Then understand what's the difference between service and resource. In AWS, the service icons are these square ones, and the resource icons are these sort of inline ones that are drawn out of lines. So you should not in every case, but it's useful. For example, the Lambda example is that if I see the AWS Lambda service icon, I immediately think that there's probably multiple Lambda functions in that diagram. But if I see just the resource icon for Lambda function, I immediately think that, okay, there's a single Lambda function here. So there's a semantic difference there. So again, it's about communicating, not inspection. There's this model called C4 model, which separates system context, containers, components, and code. I don't follow this, but I really wanted to mention because it's, even if you don't follow this, it's a good read. It sort of makes you think about different kinds of levels when you're documenting things. And also they do have these recommendations for each models, is that they recommend this context diagram for most teams, that these context diagrams just describe some high-level overview what the system is doing in high level and doesn't really pay attention to any technical details. Then there's the container diagrams that sort of describe different parts of the system, how they interoperate, and these are recommended for most teams. And then level 3 and level 4 are more detailed. The level 3 is a component diagram, how different specific components work together. And this is not necessarily recommended for every team unless they provide specific value. And then the level 4 is the code documentation. Again, I don't either recommend doing this. Maybe if you, for some reason, need this, just use some kind of a generation tool to create this. But again, not recommended. But this is go to c4model.com and read the description. It's really useful. When I'm documenting cloud architectures, I'm kind of focusing in this middle ground. So I'm targeting these, if we compare to C4 model, I'm kind of targeting these containers, and I'm also providing some of the context. And in some cases, I'm showing some of the components. Let's say if we are building some serverless architecture, so of course I might be showing like, Lambda function and things like that there. Again, it's designed at debugging and it's communication to human beings. Let's take an example at the end. So if we have a mobile application calling a GraphQL API, which integrates into third-party API and relational databases, how we describe this in AWS way. And you see, I don't follow the C4 model here at all, but still I say that that's something useful that you should check out. So in AWS, that would look something like this. You have the GraphQL, which is kind of an API gateway for, you have the AppSync, which is kind of a GraphQL gateway for GraphQL APIs. Then you have these cloud functions or functions as a service, these Lambda functions here, and they're calling the third-party API, and they also calling the relational database in RDS Aurora. So there's probably at least 2 Lambda functions, because there's the Lambda service icon and it's calling the third-party API, and also the database there. So let's try to identify some, and one reason you're doing these diagrams is that, again, when you're planning or building something new, it's easy to spot problems initially. So I'm going to go through an example, what kind of things I might be able to spot from these kind of diagrams. I'm not saying you should do a diagram that looks exactly like this, but this just is to provide some ideas for you, what kind of things you might want to add to your diagrams, and what kind of things you at least should be looking from the diagrams, and what kind of questions you can ask based on seeing some kind of a diagram like this. So let's try to identify some performance optimization possibilities. Again, you shouldn't probably do all of these, but these are just for example. So here, the Lambda functions are directly calling the relational database. As Lambda can scale to thousands of invocations concurrently, there might be actually a scenario that we're actually exhausting all the database connections. So maybe we want to use the RDS proxy service as a connection pooler. That might be useful. Okay, so we identified a potential problem there. Well, then we might also actually do some caching at some point. So maybe we utilize the AppSync services cache feature, which then caches both responses from the database and responses from the third-party API, if possible. Again, it depends on the scenario, but these are just examples. Well, talking about caching, it's always useful to add a CDN if it's like a API that is called from the internet. So it's really useful to add CloudFront distribution on front of the API gateway or AppSync or whatever you have in AWS. As CloudFront is really globally distributed CDN with over 300 points of presence. And also it's useful to have CloudFront, even if you can't cache things in CloudFront, it's useful to enable CloudFront because then your clients will be actually connecting to CloudFront edges. And from there is the fast AWS backbone network that can communicate to that AppSync GraphQL gateway. So it's really useful to add CloudFront, even if you don't cache that many things there. And of course, CloudFront needs TLS certificates if you want to have a nice looking custom domain as you usually would. So you're probably using Certificate Manager, Amazon Certificate Manager there. So we'll probably want to show it here as well. Then you shouldn't use Lambda functions to you shouldn't use Lambda functions to transport data. Instead, use Lambda to transform data. So in this example, we're not really using Lambda to modify the data or doing anything complex. So instead, we're just making a request to third-party API and fetching some results there. So we can actually use the AppSync HTTP resolvers instead and do a direct integration from AppSync to third-party API. That might be useful. One Lambda less to utilize. So now we have only single Lambda function there, and that's responsible for accessing the database. And now AppSync is directly communicating with the third-party API. But we probably want to actually cast the third-party API responses as well, depending on the use case. So we'll move it here. Then we might actually, when we're looking at it, that now there's the Lambda function that is doing something with the database. Depending on the use case, we might actually drop the Lambda function altogether because AppSync also supports these RDS resolvers that can directly integrate with the RDS data API. So we're now able to do an architecture that's something that is called functionless in a way. And it means that there's just, direct service integrations in AWS. And again, people have different opinions about this, but I really like this model because there's no, for example, no Lambda functions to maintain and monitor and update and so forth. So it's just, you define some kind of integrations in the cloud and it sort of keeps working. That's the idea here. So it's really nice way to do things. But again, this is just an example of what you could do. Let's add some kind of an expensive operation. So maybe you have some kind of a create order if you have a web store or something. This is the classic example. You have create order operation, and it's actually performed in some kind of a container in AWS Fargate, and that takes some time. There's a lot of different steps. But if there's a lot of different steps and it takes time, maybe you could also split it using step functions. So step function is really useful for these different kind of workflows. So you have the multiple steps that do something, and at some point they're probably doing some notifications with SNS. Maybe they're fetching some data or inserting some data to your data warehouse storage like Redshift in AWS or something like that. Now that we have step functions here, maybe we could actually make this step asynchronous. So when the client is making the order, the AppSync will actually respond something like order created or something like that for the client, but it will send it will effectively invoke an event in EventBridge. And what that means is that the process is now asynchronous, that the client doesn't have to wait for a response from AppSync for a long time during the order is created. Instead, the client will receive a response order created, and then the processing is asynchronous. So EventBridge receives an event, and then it invokes the step functions processing, and it does what it does. Often people then question that, okay, what if there's an error in making the order? Where the classic example, which at least many times we hear that Amazon is doing, that if there's an error, they'll actually send an email afterwards to the user that, okay, there was some error with your order. So it's kind of a asynchronous and kind of a separated process. So maybe you're integrating to Amazon Zest there, maybe just an idea. So now we just identified few performance problems, well, not necessarily problems, but potential performance optimizations, like using the connection pooling, using various caching, changing synchronous invocations to, or synchronous integrations to asynchronous integrations, and using multiple AWS services that are well suited for the task. So let's see if we can identify some authentication and security related issues here. So if we take a look at this in AWS, within AWS account, IAM roles and permissions are used to allow different services and resources to talk to each other. But you don't really need to add those to these diagrams because that's implied within the same account, because that's just how it is. If you have services and resources in AWS account communicating with each other, they are using IAM roles and permissions. In some cases, there might be like resource-based policies as well, but that's also kind of implied there. But if we are communicating with a third-party API, we probably have some kind of authentication there. Let's say we have this classic API key authentication. Well, where's the key at? It's probably in the AWS Secrets Manager, or at least it should be. You shouldn't hard-code key values to anywhere. So we might add the Secrets Manager there, that we understand that, okay, this utilizes Secret Manager as well. What about the client authentication, the mobile application, when it calls our endpoint? How does that authenticate? Let's say it uses OAuth2 or JSON Web Tokens. We might show the token there and say it's okay, it's a JWT. But how the authentication actually works? Well, we might draw a line from AppSync to Cognito, because AppSync can really nicely integrate with Cognito. That's one way of doing it. Then what about at this point you can see that the client is calling our API through CloudFront, but actually there's nothing stop the client or anyone to call our API directly if they just happen to know the endpoint. So we might want to protect our API gateway or GraphQL gateway AppSync here for those kind of purposes, that nobody can access them directly. Instead, they have to go through CloudFront. So we can add the WAF there, Web Application Firewall, which ensures that only requests coming through that specific CloudFront distribution are allowed in. Well, if we're talking about WAFs and Web Application Firewalls, we probably should add one also to the CloudFront CDN distribution. This way we can, for example, with WAF, AWS WAF, we can, for example, add rules that prevent, XSS issues and SQL injections and things like that. You can block IP addresses that have bad reputation. You can do country blocking. You can do all sorts of things. For example, when there was the Log4j issue, like when was it? Like some time back, AWS was quite quick to provide this managed rule for WAF that actually blocks most of the potential attack vectors to Log4j issues. So it's really useful to have WAF in front of your APIs. So we had the Cognito here as our authentication backend, but what if we change that to some external system? Let's say Auth0. In that case, this diagram becomes a bit weird, because now Auth0 definitely isn't on our AWS account, and so is the third-party API is not on our account either. So it's useful to define the AWS account boundary. So you use these grouping graphics that you group your resources within your account. And actually, you might have several accounts, so it might be useful to separate that. Maybe the data warehouse and the email, you might have a specific SES instance for sending email from your company, so that be on a different account. So that might be useful to define in this diagram there. Another thing I like to do is think about the stacks. And if you're working with AWS CloudFormation or CDK, stacks make sense. If you're not using CloudFormation, CDK, stacks doesn't necessarily make that much sense, but they are just way of grouping elements. But even if you use Terraform or something other, you're probably doing some kind of a packaging that you have some module or something that handles parts of this. You shouldn't really have like a one massive file describing every resource in your AWS account. Instead, you should try to make logical parts of logical grouping within your setup. For example, the classic one is always have your stateful resources, such as databases, in separate CloudFormation stacks. So that avoids a lot of problems down the way. But for the example setup we did here, I would split these resources to edge stack, which contains the CDN and others, API stack, and then the event stack that processes those events, and then the database stack. I have still a couple of slides, so I'm going to finish soon. But this is what the end result could probably look. You don't have to do exactly like this, but this is just an example that has all these notions about different kind of security and authentication things. This has external services. This has several sort of performance optimizations already in play. This has the grouping by AWS accounts, and this has also the inner grouping of stacks. So when I see a diagram like this, I'm really like happy because I can immediately identify how the application, how the system kind of works, what kind of parts it has. So again, this is kind of the extreme example, and you could probably make this even more clear by organizing things a bit better, and you might leave something out, but again, this was sort of an overview of things that you are able to add. But even if you don't add this to the diagram, you're at least able to ask these kind of questions based on architecture diagrams. So to sort of summarize, where I see the biggest benefit for these cloud architecture diagrams, they are about communication, not inspection. There are scenarios where those inspection tools are useful that generate the diagrams, etc. But it's about communicating to other people what this system is doing and what parts it has. And it's about design, not debugging. So you're doing some initial design so you can fail fast on a drawing board, on a diagram application, instead of spending hours on writing some code and then realizing this is completely useless. So that's kind of the idea here. So thank you. And that was it. Thank you for coming to this session. Are there any questions?
Yeah, there are some questions. So first of all, thank you, Ari, for such great presentation. It was really interesting. I personally noted a couple of things to work within my team about that. So yeah, we have a few questions on Q&A chat. Let me start with the first one. Doesn't all of this take effort, especially with changing architectures? Won't that mean that creating these diagrams won't be viable in smaller teams with deadlines?
Yeah. Yeah, it's definitely a valid concern that you shouldn't even in small teams and in small organizations, these shouldn't be like a blocker for if you have a deadline. It shouldn't be like a blocker that, okay, I'm going to spend 2 weeks on drawing these diagrams and it has to be perfect, and only after that we start working. No, that's not the idea. As I said, you should sort of do like the idea here is to fail fast. So you kind of sort of prototyping on the architecture diagram, trying to figure out, okay, what kind of pieces I need at least, and what problems this might have. It's easy to discuss even with a small team. If you have this diagram, it's easy to discuss with different people. Okay, we have this and this. Maybe are there any problems? Okay, there's this problem, and we could improve this. So it's really useful, and then you can start quite quickly working with it. And also, I have to mention, this is something that is not immutable. You can always do like an initial diagram and start building, and then when you realize something needs to change, you update it, you add things, you remove things, and yeah.
Okay, so the next question quite related to that. So what about someone forgetting, not bothering to reflect changes, and the diagram eventually drifting away from reality? So it's connected.
That is the problem, and that is the kind of the biggest argument that people who advocate these generators is, and it's kind of a valid argument that not everyone always remembers to update the diagrams, and then it's out of sync, and probably out of sync documentation is worse than no documentation at all, at least in some cases. But it kind of there is no there's no silver bullet answer that solves this. Instead, it takes kind of as a team, you need to have, I can't find the word, but kind of a practice, or like it should be a convention in your team that you try to keep those diagrams sort of up to date. But again, you shouldn't go to too much detail there, because if you have too much detail, then it's hard to at least try to have the high level building blocks in place. So it's like the starting point that you looked at, okay, the system looks about this, and when you need to go to detail, you actually look at the infrastructure code, or actually go to your AWS accounts and see what's happening there, and things like that.
Yeah, so maybe before I will go with the next question from the chat, I will ask my question, because it's it could be related to this topic, that so how we can work within our team, within our organization, on that approach of communicating via diagrams, or even culture of communicating via diagrams. Yeah, because I'm assuming that if everybody will have that culture, himself or herself, that we are using the diagrams, so yeah, it's even easier to communicate via this way. But how to start, maybe?
Yeah, how to start? Well, usually what I've seen, there's like one or two persons per team that are more into this topic. So of course it needs some sort of champion who is like pushing this mentality forward. But sort of day to day, it's more like that when somebody is doing something new or creating some new features, something, they're reflecting that on the diagram, and they're just doing it there. Maybe for example, if it's a dry or diagram and it's in the repository, maybe they're doing like a pull request. They could do like a draft pull request. And what I encourage people, depending what you're doing, do draft pull requests and let your teammates know that, okay, here's the idea what I'm trying to do, and they can take a look at it. Okay, looks good. And then the person starts working, and then they set the pull request ready for review. And the diagram could be part of the pull request. That's the beauty, for example, in GitHub for pull request. It's that you can have, images there or whatever, assets there. So the diagram could be part of the pull request as well.
Yeah. Great approach. Okay, so the next
and one quick thing I have to mention about the pull request, that we're using pull request templates. So for a pull request template, you could actually set a comment there that if you have a diagram, add it here. So that sort of encourages people to add if it's a some kind of a cloud architecture they're working on. So one idea there.
Yeah, of course. Thanks for that. Okay, so the next question from chat: isn't reasoning about things like icons and layout, formatting, etc., in a way of bike shedding, something that doesn't deliver much direct value for many people working software, faster onboarding, and so on?
Yeah, again, yeah, and I'm not saying every team has to do this. This is, of course, depends on your context. So if you are, for example, a smaller organization and you have a small team that is really focused on the product, and if it's something that you can sort of keep the mental model all the time in your head, then you don't necessarily need these. But if you're a larger organization with multiple teams, and some bigger and some smaller teams, and if there's some context switching happening, that there are many projects and so forth, so then it actually makes a lot of sense, because if you don't have anything like this, then the context switch, if you're switching to a new project, or if there's a new person or something like that, the context switch takes so much time. So it's really beneficial to have these. But again, it really depends on your organization and team structure and conventions and things like that. Yeah. And I have to clarify, I'm not saying everyone has to do this. I'm sort of advocating that you should really consider doing this if this works for you.
Yeah.
Depends.
Yeah, as always, and everything.
As always.
Yeah, as always. Okay. And last but not least question, on the icons PowerPoint download, is there an equivalent to Google Drive presentations?
I don't know. I haven't used Google presentations that much, so I can't know. But you should go to was it awsamazon.com/architecture something? Go to Google, put AWS architecture icons. You'll find the correct page there. So there's listed pretty much all the official resources that AWS provides. And same goes for Azure and GCP. I would assume GCP would have that, but yeah, but if you don't have that, if you're working with Google, presentations, and you don't have a PowerPoint, then you can just download the assets package that has, SVG, graphics, EPS, and PNG and other formats. So you can just, use those in that case.
Yeah, exactly. Okay, and the last question, I saw that there was one more question on our chat. Do you use auto-generating diagrams? If so, what do you use for auto-generation in AWS?
Yeah, I'm kind of I don't really use that much auto-generation. As I said, that I don't really see the benefit of doing auto-generation during development, because you should sort of have the mental model in that scenario already, so you don't really need that diagram there. But diagramming is useful when you try to inspect something new. But uh, to be honest, I'm in a good position that most of the stuff we've done for several years, they are done through infrastructure as code. So let's say CloudFormation, things like that. So if I need to debug some new system, if there's no documentation, I'm just going to look what kind of a CloudFormation stacks there are, etc. But AWS perspective is the AWS official one. That might be really useful. It looks really good. And as it's AWS official, it should work. But there is a pricing scenario because it uses AWS config and other things in the background, so it can become pricing. So I would probably, depending on the use case, I would probably check out the AWS perspective for a specific use case just to get some idea what's there happening, and then disable that because I don't want to leave it running for all the time, generating cost. But that would be probably something that I would use.
Okay, Ari, that's all from our chat. So we are a little bit out of time. So thank you again for your great presentation.
Oh, thanks for having me.
Yeah, I really enjoyed that presentation. And yeah, now we have 10 minutes break, coffee break, and we will see within 10 minutes on the next presentation. So yeah, see ya there. Bye.
Yeah.
Thanks, Ari.
Thanks. Bye.